Hi, so for today we're going to talk about integral calculus, and this is my very first video about integral calculus. So let us start first with the definition of integral calculus. What is integral calculus? Integral calculus is basically the branch of calculus that deals with the theory and application of what we call the integral. Now, the integral or the integration is basically the process of getting the integral of a derived function. So in other words, when we talk about integration or integral calculus, it's basically the opposite of differential calculus. So given a derived function, we're going to get the integral. So the result should be the original function. Or in other words, integration is also known as the anti-differentiation. So whenever we do integral, we're getting the original function of the derived function. Okay? So so here's the symbol for integral, just like this. Yeah. So integral symbol. So this is the integral of f prime of x dx, which we call this f prime of x as the integrand. That's the derived function dx, and that should be equal, again, as I've said a while ago, to the original function, f of x plus a certain constant c, because the derivative of a constant is always 0, so we might never know if there is a constant here. For example, the derivative of x squared plus 2. So the derivative of that is 2x. So when we get the integration of that, we should include the plus c, which represents the 2. Okay, so whenever we do integration, we're always finding the original function, okay, of the derivative of the derived function here. Okay, so in other words, integration is the opposite of differentiation. Okay, in differentiation, you're given a certain function, then you're going to get the derivative of that. That should be f prime of x, for example, or y prime. Now, when we do integration, we're getting back to the original function. Okay, our goal is to get back to the original function. Okay, so let me just introduce to you to the basic integration formulas. So for number one, the integral of 0 dx is equals to c, okay, which is a constant. So for example, what's the derivative of 2? That is 0. When we get the integral of these two, it should get a constant. Basically, 2 is a constant. So, but we never know what that constant is. But we know that it is a constant. So, we always write c. Okay? So, yeah. So, for number 2, the integral of a dx is equals to ax plus c. So, for example, where a is any constant. So, for example, the integral of, let's say, 2 dx, okay, we can actually move the constant outside of the integral and evaluate the integral. For example, integral of 2 dx. Okay, so here we can actually uh, transpose, or let's say move outside the integral symbol, the constant 2, and evaluate this integral. So the integral of dx should be simply x. Okay? The integral of dy should be simply y. The integral of dz should be simply z. When we get the derivative of this, we are left with 2. Okay? So, if you get what I'm trying to say, here is this. Our original function is y is equals to 2x. So, if we get the derivative of y with respect to x, that should be 2. And when we cross multiply this, what will happen is that dy is equals to 2 dx, so that when we get the integral of both sides, we shall be arriving again to our original function. Okay, so again, when we get the integral, we should note that we should have plus c here, okay, to denote that there is any constant. Okay, so number 3, the integral of a of f of x dx is equals to a, the integral of f of x dx. So for example, given a function, just like what I've said a while ago. So we can actually bring out the constant a out of the integral f of x. So to look our integral much easier. So here we have also, we're going to find the integral of the sum and what do you call this, difference of two certain f functions, f of x, g of x, that is the derived function of dx. So we can separate, or we can simply distribute the integral sign and the dx as individual. Okay, we can evaluate the individual integration of purely the integral of f of x dx plus or minus the integral of g of x dx. So we can always do that. Okay. For number 5, we have x integral of x raised to n. So this is a function, or any certain variable raised to some certain power. Okay, we can use this formula, x raised to n dx is equals to x raised to n plus 1, where n should not be equal to negative 1, divided by the n plus 1, plus some certain constant again. Okay? So, let's try to solve some problems. I have here 10 problems and I hope we can solve it. Okay? Very fast. So, for number 1, we have the integral of x raised to 5th dx. Now, we're going to apply here our formula number 5, which is integral of x raised to n dx is equals to x raised to n plus 1 over n plus 1 plus c. So, since our n here is not negative 1, we can apply. So, okay? So, what will happen is that x raised to 5 plus 1 over 5 plus 1, we say that whenever we do integral, we always include plus c. Okay? So, we're going to simplify that. That is x raised to 6 over 5 plus 1 is 6 plus c. Or we can also rewrite this as 1 over 6 x raised to 6 plus c. So, this should be our answer. Okay? So, if you want to check if you really find the integral correct or solve the integral correctly, so what are you going to do is to get the derivative of this. So, if you get the derivative of this by power formula again, 6 times 1 over 6, that is 6 over 6, that is 1, minus 1 to the exponent, that leads you to x raised to 5. So, you know you got the correct integral by differentiating your final answer. Okay? Now, for number 2, we have the integral of dx over x squared. So, before you are going to, actually, we can simplify this. So, integral of x raised to negative 2 dx. And hence, we can apply the power formula because the exponent here is not equal to negative 1. So, if we're going to get the integral, x raised to negative 1 plus 1 over, or negative 2 plus 1, negative 2 plus 1 plus c. Hence, we can simplify this. X raised to negative 1 over negative 2 plus 1 is negative 1 plus c. And we can rewrite it as negative 1 over x plus c. So, that should be our answer. This should be our answer. Likewise, for number 1, this should be our answer. So, for number 3 is the integral of the cube root of z dz. Okay. So, whenever we encounter a rational derived function, we should always write this into power. Okay? So, that is equal also to z raised to 1/3 dz. So, we can use power formula again, z over raised to 1/3 plus 1 over 1/3 plus 1. So, 1/3 plus 1 is 3 times 1 is 3 plus 1. That should be 1/3 plus 1, 4/3, diba? So 7 raised to 4 thirds, z raised to 4 thirds over 4 thirds. Yeah, 3 times 1 is 3 plus 1 4 thirds. So, to simplify this, bringing up this, the reciprocal of this, we have 3z raised to 4 thirds over 4. So, in other words, plus c, don't forget, or in other words, we have 3 fourths of z raised to 4 thirds plus c. For number 4, we have dx, we have the integral of dx over cube root of x squared. So, cube root of x squared. So, again, you must rewrite this in our exponent form. So, as you all know, 2 thirds, that is dx over x raised to 2 thirds. Diba? So, we can actually translate it into x is equals to negative 2 thirds dx. So, what are you going to do here is, we have again a power formula. So, to evaluate the integral of this, x raised to negative 2 thirds plus 1 over negative 2 thirds plus 1, don't forget the plus c. Okay. So, we have negative 2 thirds, that is 3 times 1 is 3, plus negative 2, 3 plus negative 2, or 3 minus 2 is x raised to, oops, that should be equal to x raised to 1 third over 1 third. So, plus c. To simplify, we have now 3 times x raised to 1 third plus c. Okay. So, that should be our answer. So, for number 5, we have here the integral of 2x squared minus 5x plus 3. 2x squared minus 5x plus 3. Integral of 2x squared minus 5x plus 3 is equals to, or dx. So, we can now apply our formula here for number 5 question, our sum and difference. Okay? Which means we're going to evaluate that integral as this. So, we can distribute the integral. So, 2x squared dx minus 5 integral of 5x dx plus the integral of 3 dx. So, again, using our rule, we can actually remove the constant outside of the integral sign. So, we can simplify this as 2 integral of x squared dx minus 5 the integral of x dx plus 3 the integral of dx. So, then we can, so for that, so 2, the integral of x squared is again by power formula, x raised to 2 plus 1 over 2 plus 1. Okay? So, minus 5. This is still a power formula. Its exponent is 1. So, x raised to 1 plus 1 over 1 plus 1 plus 3, the integral of dx, so I've said a while ago, should be simply x. And we don't forget to write plus c at the end. So we have here 2 raised to x cubed over 3 minus 5 times x squared over 2 plus 3x plus c. So simplifying, we have now 2 thirds x cubed minus 5 halves x squared plus 3x plus c. So here is our integral of this derived function. Okay, so as you can see, if you get the derivative of this, you should arrive at this derived function. Okay? So for number 6, we have 1 minus x times square root of x. So 1 minus x times square root of x. So number 6, the integral of 1 minus x times square root of x, that is dx. Okay? Again, when you see a rational function, we're going to convert it into exponent. So square root of x, simply x raised to 1 half dx. And probably you can distribute this x raised to 1 half on the other side, 1 minus x. So that should be x raised to 1 half and minus x raised to 1 half times x. The exponents will add, of which the exponent of this is 1. 1 plus 1 half, that should be 3 halves. X raised to 3 halves dx. And again, you can distribute the integral and the x sign. Integral of x raised to 1 half dx minus the integral of x raised to 3 halves dx. So, by power formula, so what will happen? X raised to 1 half plus 1 over 1 half plus 1. Oops, let me just erase that. So that should be 1 half plus 1. Okay? Minus x raised to 3 halves plus 1 over 3 halves plus 1. Okay? Plus c, of course, at the end. So evaluating x raised to 1 half plus 1, that is x raised to 3 halves over also 3 halves. Minus 3 halves plus 1, x raised to 3 halves plus 1, that is 2 times 1 is 2 plus 3, that should be x raised to 5 halves over 5 halves plus c. So simplifying, we have 2 thirds, okay, of x raised to 3 halves minus 2/5 of x raised to 5 halves plus c. That should be our final answer. Okay. So for number 7, we're going to solve again 3s plus 4 quantity 3s plus 4 squared. So we have number 7, the integral of 3s plus 4 squared ds. So first, we're going to expand this binomial. So we have 3s 9s squared plus 4 times 3, that's 12, plus times 2, that is 24s plus 16, okay, ds. And again, using our basic formulas a while ago, we can distribute the integral sign. So 9s squared ds plus the integral of 24s ds plus the integral of 16 ds. So what are you going to do? We have constants, bring them out of the integral. We have s squared ds plus 24 integral of s ds plus the constant 16 integral of ds. And if we're going to get that, so simply we have 9 times s cubed, that is s squared plus 1 over s2 plus 1, that should be 3, plus 24 times s squared over 2 plus 16 integral of ds should be simply s plus c. So simplifying, 9 divided by 3 should be 3 and 24 divided by 2 should be 12. So we have here 3s cubed plus 12s squared plus 16s plus c. And this should be our answer. Okay? So, for number 8, We have integral of x cubed plus 5x squared minus 4. So, number 8. Oops. Number 8. Number 8, integral of, let me see again, x cubed plus 5x squared minus 4. X cubed plus 5x squared minus 4. X cubed plus 5x squared minus 4. If I'm not mistaken, that is divided by x squared dx. So that just, let me check again. Okay. Okay. We got it correctly. Okay. So, in order to find the integral of this, we can simplify this integral as, this can be rewritten as integral of x cubed over x squared plus 5x squared over x squared minus 4 over x squared dx. Okay? So, applying the rule again of sum and difference, we have the integral of, we can simplify this, or integral of x cubed over x squared dx plus the integral of 5x squared over x squared minus the integral of 4 over x squared, or dx. I'm sorry, still to have dx here and dx here. Okay? So, we can simplify this. The integral of this would cancel. Simply x dx. And we can factor out 5 here. So, simply x squared and x squared will cancel. So, that should be dx. And we can move this constant 4 outside of the integral sign, and that should be 1 over x squared dx. And then you try to integrate. So integral of x dx should be x squared over 2 plus 5 times the integral of ds, that is simply x, minus 4. The integral of this function is x negative 2 plus 1 over negative 2 plus 1. Okay, so we have brought down or bring up the function so that it will have the negative exponent and apply power formula. So, yan, plus c. So, what are we going to do is just to simplify x squared over 2 plus 5x minus 4, x raised to negative 2 plus 1, that should be x raised to negative 1 over negative 1 plus c. Simplifying further, x squared over 2 plus 5x plus, okay, 4 over x plus c. Okay, it became positive, this plus, because of the negative here and the minus sign here. So negative minus times a negative value, that should be a positive value. So we bring down x to eliminate the negative exponent. So here is our answer for our integral. And for number 9, we have here, number 9 is the integral of x plus 1 over square root of x. Integral of x plus 1 over square root of x dx. So same process, what are we going to do is to evaluate the integral of, we can rewrite this as x over x raised to 1 half, okay, plus 1 over square root of x, or x raised to 1 half dx. Now, let me just rewrite this as x raised to 1 half. X raised to 1 half. Then we can simplify. Okay, this has a exponent of 1, has an exponent of 1. So 1 minus 1 half, we should have an exponent of x raised to 1 half. Okay, so plus 1 over x raised to 1 half dx. Okay, that is in quantity. Okay, so what will happen is the same process. the same that we do from our previous example. So we have integral of x raised to 1 half dx plus the integral of 1 over x raised to 1 half dx, or simply we can rewrite this term as x raised to negative 1 half. So integral of x raised to 1 half, that is x raised to 1 half again plus 1 over 1 half plus 1 plus x raised to negative 1 half plus 1 over negative 1 half plus 1 plus c. So we have x raised to 1 half, that is x raised to 3 halves, and we have here 1 half plus 1 over 3 halves again. So plus x raised to negative 1 half plus 1, that should be x raised to 1 half, and this should be also over 1 half plus c. Okay, so what will happen is simplifying 2/3 of x raised to 3 halves plus 2x raised to 1 half plus c. So we have evaluated the integral of that derived function. Okay, so for our last number, it's the easiest one, if I'm not mistaken. So simply, integral of dx, okay, integral of dx should be equal to x. Am I correct? Is this our final answer? X? Yes, that's not our final answer. Our final answer is x plus c. Okay? So, here are some basic integration formulas and basic examples. So, thank you so much for listening, and God bless you.